In this video, we see some exercises on the use of the Scenario Manager tool in Excel. Then we see some example of data table use, and then we conclude with an exercise on goal seek. These exercises are in section 3 of the exercise book. Section 3 actually includes also exercise on solver, but we'll address solver later. So in order to do this exercise on Scenario Manager, we have first of all to create in an empty worksheet a table to analyze the revenues of a company. So I strongly recommend that you stop the video and you try to create this table by yourself. So basically, there's an example of the table in the slides here. So basically, we want to analyze the revenues for each trimester. We know that the company during the first trimester sell 100 pieces at 10 euros each, and we know that the production grows of 20% every semester. So we have to, in addition, we know that the production has some fixed costs that are 300 euros if the production is below 140 pieces, otherwise it is 500 euros. The production of each product costs 3 euros in consumable. So we have to create a table like this where all the cells in yellow are automatically computed, and then we want to evaluate the cumulative net income. So what is in white are the parameters provided by the exercise, and everything else must be computed automatically. So let's see. So again, I suggest you stop the video, try to create this table by yourself, and then we see the solution together. So let's take an empty worksheet. Let's start creating our table. So I put here first trimester. Let's put some headers, so we remember what each cell is about. That we put here production or amount, whatever. Price, that's the price we sell the product. Income, fixed cost, fixed costs, production costs, total costs, net income, net, and then cumulative net. Okay, so let's add some borders. There we go, and also let's separate the 4 trimesters. Then I have to add another field here, growth, 20%. Okay, so this is a parameter that I can change in order to see what happens if the growth will be higher or smaller. So what the data we have, the information we have is that production during the first trimester is 100, the price is 10, and then the production cost is 3 euros. Okay, so let's set the format of all these cells in currency. Okay, so now we can try to fill in the table. So first of all, okay, let's fill in the production. So we know that the production grows by 20% every trimester. So the production during the second trimester will be equal B2, production in the first trimester, multiplied by 1 plus growth. Since I'm going to drag the formula, I have to use absolute references. Okay, so during the second trimester, the growth is 120, 144, 172. Price doesn't change, but I cannot just drag the values here, because if I want to see another case where the price is higher or lower, then I want to modify only this cell. So equal B3, and then I drag. So in this way, if I change the price, I automatically modify the price in all the other cells of the row. Okay. So the income is just production multiplied by price. And then I can drag. Fixed costs, I have to use a formula here because it depends on the production. So equal if production is smaller than 140, it's 300, otherwise it's 500. For what concerns the production costs, again, I have to copy the value. Okay. The total costs I have is production costs multiplied by the number of pieces I produce plus fixed costs. Okay. So my net for each trimester is the income minus total costs. Okay. The cumulative net is sum of all the single trimester nets. Okay. So let me also paint in yellow what I have automatically computed. Okay, and this is, let's put this in green. Okay. So you see that if I change one of the blank cells, like for instance the growth, the table here is automatically updated and I have a new value for the cumulative net here. The same if I change, for instance, the initial production. Okay. So what I can do, of course, so I can change this value and see what happens. However, of course, changing manually is a bit complex. Excel provides us with a tool to do this in an automatic way. And this tool is the scenario manager. So basically using scenario manager, now we want to evaluate what happens to the cumulative net if we have these 6 different conditions. So we will do only the first, the third, and the last one. Okay, because then it's quite mechanical. So we see how we can create these different conditions and switch between them, evaluating how the cumulative net changes. So to do this analysis, we can use data, what if analysis, scenario manager. However, before using the scenario manager, one useful thing to do is to give labels, so to give names to the relevant cells. This will ease the creation of the scenario manager and the analysis of the results, and also will be useful when playing with other tools like Solver, for instance. So let's assign to cell B2 the name production. So to do it, select B2 and then here in the name box write production and then enter. In B3 price, then enter. B6 we're not going to use it. The 3 cells that we change is the growth, the price, and the initial amount. So growth. Sorry, I mistyped. And then also let's give us a name to the cumulative net, which is the results we evaluate. Cumulative net. Enter. So at this point we can create our scenarios. So data, what if analysis, scenario manager. So the scenario, there are no scenarios defined, so we can start creating the current one. So add, we can you have to give it a name, current. By changing cells, we have to select the cells that you want to modify. So we can use Ctrl and select B2, B3, and B10. Okay. So you see that we have the names here we just gave. So these are the current values. If we want to create a different scenario, we have to change these numbers, but for the moment, this is the current scenario, so we don't have to change the results, to change these results. Okay. Then we can create another scenario, considering, for instance, the first condition here. So the growth is 30%, price is 10, and the initial amount is again 10. So add, let's call it scenario 1. Okay, so here we have to change the production and price are not changed. We have to change the growth to 0.3. Okay, so now you see that we have the second scenario. So if we select and then press show, you see that we automatically switch to the second scenario. Go back to 1 again. So when you switch between scenarios, it's like you are actually typing the numbers in the cells. So if it's like typing the values inside. Okay, there's no memory, it doesn't keep trace. It just stores some numbers and put the numbers you want to, the new numbers in the cells you selected. So let's see what happens if you create another one. So we say the number 3. So in this case, growth is 30%, price is 12, initial amount is 95. So add scenario 2. So production is 95, price is 12, growth is 0.3. Growth is 0.3. Okay. Show. Okay. Scenario 1. Show. Then let's add finally the last one. So the growth is 10, price is 12, initial amount is 95. Add scenario 2, 3. Okay. So production is 95, price is 9, growth is 0.10. Okay. Sure. As an exercise, you can try to create the remaining scenarios, the 3 scenarios we didn't address. So having the possibility to swap between different scenarios is interesting because you can quickly evaluate what happens. However, it's good for a live presentation. However, if you want to have an analysis of what happens in the different conditions, that is not very useful. It will be much better to have a summary with all the results. And Scenario Manager provides this tool. So you press on Summary here, Scenario Summary, select the result, what is the relevant cells. It's E9 in our case. You can select more than one, of course. So Excel creates a new worksheet where you see we have the cells that we want to change with the changing values, and then the cumulative net. So you can have in a single shot, in a single view, the different scenarios and how the cumulative net changes in these different conditions. So this is useful. It's nice for if you want to give a presentation. However, if you want to do deep and exhaustive analysis of what happened, because you're trying to maximize some parameters, to optimize some parameters given that you want to maximize the net, cumulative net, this tool is not sufficient. It allows you only to evaluate some finite number of small and finite number of cases. For a deeper analysis of what happens when some parameters of your table, some numbers in your table change, you can use data table. So this is the exercise that we want to do now. Given the problem, the previous exercise, the previous slides, we want to use data set table to evaluate how the total net income changes when growth varies from 5 to 40% and price from 8 to 10 to 15%. Okay, so let's go back to our Excel document, sheet 1, where we have the solution. So to do this, first of all, you have to create, I put the relevant cell here in the corner of my table. So let's assume that we want to develop our data table analysis in this area. So equal cumulative net. Then I create a series of possible prices, 8, 9, up to 15 along the row here. a series of possible growth from 5%, let's say with step 5, so the next one is 10%, up to I get 240. Okay. So what I want to do, for each combination, price, growth, I want in the corresponding cell the cumulative net that I will get replacing these numbers in B3 and B10 respectively. So data, what if, data table. Okay, this is the data table menu. So row input cell means the numbers in the row here. Okay, where do I have to put these numbers in the table? And it's in B3. So now I'm telling Excel to evaluate one after the other all these numbers, 8, 9, 10, 12, 12, 13, blah, blah, blah. For each of them, put it in B3, take the cumulative net and put it in the column. Column input cell is the cell where the numbers along the column here have to go, and in this case is the growth. So for each pair, Excel will take the number, for instance 11, 15, will take 11, put it here in B3, take 15, put it here in B10, take the results and put it in the corresponding cross point. So, okay. This selection isn't valid, make sure to copy paste the areas. Okay, sorry. Select the area, data table again, row input cell, B3, column input cell, B10. I selected in the previous, I selected the rows and the columns, so I lost the selection. You have to select the area where the data table is. Okay. Set the program format to currency. And you see that we have the cumulative net for different values of pricing. So if we take 10 and 20%, here we have exactly the current value. Okay, so now let's see another exercise on data table. This is exercise 3.2. So this is the first part of exercise 3.2 in the exercise book. So in this exercise we assume that our small company produces two products, product A and product B. So product A, we can sell it at 8 euros and it requires 0.7 hours of the production plant. The cost of the production plant is 5 euro per hour. Product B is more expensive, we could sell it at 15 euros, but it needs 1 hour of the production plant. So probably it's a more elaborated product, so we can sell it at a higher price, but it takes more time to produce it. We can expect from some historical data we have that we can sell at maximum 100 products of type A and 60 products of type B. And then we have also 500 euros of fixed cost, which are independent of the production. So in the first part of the exercise, we have to create a table similar to the exercise before to evaluate in an automatic way the total net profit for a given production. So if you see the table here, 90 and 55 are our variables. We have some predefined some parameters, some constraints, so the product price for each product, how many hours we need, how many pieces we can sell, how much the production cost, and so on. So we have to find a way to compute the total net in an automatic way as a function of 90 and 55. Then, using data table, we want to analyze how the total net profit changes for different production of product A and product B. So let's take our Excel document. Let's create another worksheet. Okay. So let's put it here, product A, product B. Okay. Let's consider the production here. Production, so the number of pieces we produce for product A and product B. Set it to 90 and 55 as in the exercise. Then we have the price per product here. Price per product, it's 8 euros and 15 euros. Then we have the production hour per product. This is 0.7 and 1. Okay. And the maximum number we can sell. Max sell, it's 160. Okay, so we want to compute the net profit for each product and the total net profit. Let's put here cost per hour, production cost per hour, it's 5 euros. And then the fixed cost, it's 500 euros. Currency, and also here I set these two cells as currency and this as currency. Let's drag some borders to clarify, to make the table more readable. Okay. Okay, maybe with respect to the access to the table reported in the access in the slides and in the exercise book, it's better to split the computation of the costs and the computation of the total net of the income. Okay, so let's put it costs and income. So the income is basically the production multiplied by the price. However, we have these constraints on the number of pieces that we can sell. So even if we produce 110 pieces, we can only sell 100. So there are a couple of ways to do this. So this is equal to price multiplied by. So here you can create an if, for instance, if B2 smaller or equal than B5, we return B2, otherwise B5. Okay, so we check if it is smaller than 100, we return the value. If it is above 100, we return 100. Or we can consider the maximum between, sorry, the minimum between B2 and B5. Okay, so it's the minimum. So if B2 gets higher than B5, it returns B5, otherwise B2. Okay, so let's try. So 90 pieces, we have 720. 110 pieces, we have 800. Ctrl C, Ctrl V to copy the formula. For what concerns the cost, instead I don't have these constraints, so the costs are based on the production. Okay, multiply by the number of hours I need for each product, multiply by the production cost, the cost per hour. So 90 pieces times how many hours per piece, multiplied by the production cost. I use F4 for the production cost because then I want to Ctrl C, Ctrl V, copy paste. So the net profit for each product is income minus costs, and the total net is total net of product A plus total net of product B minus the fixed costs. Okay, I put the fixed cost here because I have to count them only once. Okay, so let's put this in orange. And this in green. Okay, so you see that now if I change the production of product B, the result changes. The same if I change the production of product A. Okay. So now the exercise requires to evaluate how the total net changes as a function of the two production, product A and product B. So let's do it table here. So equal B9. Let's consider possible productions with step of 5, starting from like 40, 45. Let's assume that this is product B. Let's go, this is product B, so let's go up to 60. And again, 40, 45. This is product A, so let's go above the maximum, this 130. So as we did before, select the range of cells, data, what if analysis, data table, row input cells, we say that it is the production of product B, column input cells is the production of product A. Okay. Set the format to currency, home currency. Okay, so basically you can see that the maximum number is here. Okay, so the optimum production is, of course, you have to produce all the pieces that you can sell. You see that if I produce more pieces of product B than what I can sell, the total net decreases, and the same occurs for product A. If I produce more than 100 pieces, then the total net decreases. So obviously the best value is here, when the production matches the number of pieces that you can sell. Okay, of course this exercise is oversimplified. Typically you have other constraints, and we will see when we address the solver tool how to find the optimal solution given some constraints that have to be matched. So let's complete our video with the final exercise on goal-seek. So to do this, we have to use the laboratory.excelExe06 Excel document, and we have to consider the worksheet goal. In the first part of the exercise, we have to revise a little bit mathematical functions. So in column B, we have to create a function f1 of x, which is cosine of x divided by x. In column C, we have this second order formula, 3 times square x minus 2 times x minus 5. And in column D, we have this other function, which is logarithm base 3 of square of x. So after we have created these 3 functions, we have to use the goal-seek tool on cell A2 for function 2, 3 to find the value for which the functions are equal to 0, and then the value for which the two functions are equal to 2. So let's take our Excel document, laboratory solution, worksheet, goal. So in column A, we have some value of x, and for each value of x, we want to calculate the results of f1, f2, and f3. So f1 equal cos, open parenthesis, a2, close parenthesis, divided by a2, double click. f2 is equal to 3 times, then the square of, we have to compute the square of a2. Here we have multiple ways to do it. We can multiply a2 by itself, or we can use hat 2, or we can use the power function of a2, 2. Of course, the power function is more useful when we have non-integer exponential or particular exponential. In this case, let's use a2 hat 2 minus 2 times a2 minus 5. Double click, and then f3 equal to log, open parenthesis. So you see that we have log 10 or log. Log means that you have to specify the base. If you don't specify the base, then it takes base 10, I think. a2 square semicolon 3. Okay, so we have created these three functions. So what we want to do now, we want to try to modify the content here of a2 in such a way that the result of f2 is equal to 0. To do this, we can use the goal-seek tool. So let's see how it works. Data, what-if analysis, goal-seek. Okay. So the first argument we have to set is set cell. So we have to define the cell of the worksheet where we want our target value. To value 0 by changing a2. Okay, so now when I press OK, Excel will try to modify the content in a2 in such a way that in C2 it gets something very close to 0. The process is a sequence of iterative approximations, so it will never get exactly to the correct number, but it will get very close to the target number. Press OK. So let's see, it takes a while, and that's the result. The target value is 0, the current value is 0.000017, so very close to 0, and it is obtained when x is equal to -1. So if you press OK, you keep the results. If you press cancel, you restore the original values. Let's press OK. So if we scroll down, you see that f2 is actually equal to 0 here between row 32 and row 33. So between -1.04 and -0.97. So the result makes sense. Okay. So what the important thing when you use goal-seek is that there is a relationship. It doesn't have to be direct, like in this case. There could be it can be indirect, so it could be other functions, multiple functions connecting the two cells. But what matters is that when you change a2, these changes affect the result in C2, so that Excel can find the value for which you can get the target value. If you try to get 2, let's try to get 2 in second for F3, for instance. Then you can try to address the other cases. Goal-seek, set cell D2 to value 2 by changing A2. So it takes a while, and then we are not so close. The fourth decimal digit is different, but you are very close to 2, and that is obtained when A2 is equal to -2,999,801. Okay. So before we conclude the exercise, there is another thing to take into account. So now if you scroll down F2, you see that it's a second order function. So typically there are two solutions. So you see in fact that it is equal to 0 somewhere here between -1 and -0.97. And then again here between 162 and 167. So in case there are multiple solutions, typically goal-seek finds the solution closest to the starting point, to the starting point, to the original value, because it is an iterative process. It's checked how far the result is, modify the input, and so on. So let's try again. What-if analysis, goal-seek, set in C2 we want 0 by changing A2. We see that you get -1. You see also the distance between the target value and the current value decreasing when Excel is processing. So now let's see what happens if here I set 6 as original value. what if analysis, equals seek C2 to 0 by changing A2. And you see that it finds the other results because the second solution, this solution is the closest one to the original value, to the value originally stored in A2. Okay. So as I said, you can try to play with the other cases. So trying to find where f3 is equal to 0 and 2 and see what happens when there are multiple solutions.